Uh, this is doubt solving session and I'm going to solve two questions that has been asked by Amit, okay, in the group, WhatsApp group, right? So these questions are not that difficult. I'm pretty sure that you guys might be watching the question and might be getting stuck, okay? See, you know the concept, but still you are facing a lot of doubt, right? That you have to accept and you have to learn, right? Okay, that's what I always suggest कि जब आप क्वेश्चन देखते हैं तो आपको समझना है कि whatever you have learnt in the class, right? How can you use them, okay, in the circuit? So let us solve this question. It's a very simple question, and you can say you can solve this question in one line, right? If you know the concept, okay? So let us move to our favorite screen, and this is our second question, and this was the first question. In fact, this was asked in GATE 2009, and the same question was asked in 2012, right? So you can see here, this is kind of proof also that if you are solving all the PYQ honestly, right, without looking at the back solution, and you are solving these questions, okay, all PYQs, so certainly you might get some repeated question as well. And this is the reason. I mean, you can see in front of you in 2009 the same question, and in 2012 same question, right? So let's solve this question. So what is this question? सबसे पहले आपको your reading should be very good, right? I mean, you should read the question very carefully. Don't focus on the circuit at this moment. Reading the question, the source network is there. S is connected to the load network L. So there are two networks. Okay, one network is source network, and one network is load network. Uh, Shown by the dash line, okay, the power transfer to source to L would be maximum. So they want maximum power to transfer to the load RL, okay. Understand? When RL is what will be the value of RL, right? So remember that whenever there is a source network, you can say this source network, and this is a load network, okay. So this is a source network, right? Single source is given. This load network can also contain the DC voltage source, okay, as well as the resistance. So usually you will find resistance in the load network, or they might connect resistance as well as some kind of a DC voltage, right, by saying that this is a load network, okay. So you don't have to worry about it, right? Okay, so they have connected like this, right? So whatever current is going to flow from, you can say, from source network, that will also go to load network and it will come back, okay. So it will be like this, understand? I believe this is fine, yeah. So source network is there and the load network is there, and whatever current is because of source network, okay, the same current is gonna flow to load as well and then come back, okay. And this circuit is not any sort of AC circuit. Here all the sources are connected, here all DC sources. So if there is a capacitance also present in the circuit, right, or inductance, so they will be either will be replaced by open circuit or short circuit, right, depending upon, suppose capacitance is there, so you can remove that capacitance by open circuit, okay, because at DC the reactance is going to be infinite, and if there is an inductance you can replace it by short circuit, right? That is the very simple idea. Now, as long as you know that the maximum transfer, you want to transfer the maximum power, right? So I think you guys can recall, okay, just I'm going to tell you that suppose any network is given, okay, suppose this is a network, okay, and there is a load resistance RL, right? So you can Theoremize this entire network. This network will be having resistance and kind of voltage source, right, like this, okay. So you can look back to the network and you can make this black box as RTH, and this is nothing but a VTH, okay. And then again you can connect back the RL, right? So if you want a maximum transfer power to the load here, right, okay, RL, so what you have to make sure that you know that from maximum power transfer theorem, maximum power transfer theorem, TT, you can say, the load resistance should be equal to RTH, okay, or you can say the load resistance must be equal to RTH, okay, or source resistance, okay, if there is a, if you consider this RTH as source resistance, okay. So it's a very simple picture, right? So So then you will find the maximum power. Okay, so let me come back to the question here now. So you see here, this is a source network. So what you can imagine here is that here one resistance is there, right? Kind of resistance is there. That is nothing but is equal to what? That is nothing but is equal to the source resistance, which is 2 ohm. Okay, you can imagine like this. You have to imagine. Okay, so if you are imagine, if you are making assumption that there is a 2 ohm resistance, what will be the voltage across this? Forget about this load resistance. Okay, sorry, load network for the moment. So आपको यहाँ पर कितना voltage आएगा? You know, the voltage across this will be 5 volt. Okay, because this is 10 volt and you can say there is a 5 volt. Okay, so if you ignore this load network for the moment, right? So because we want to find the this load resistance, okay, appearing across this source network. तो आप देखो यहाँ पर कि क्या है, ठीक है? तो it will be 5. Okay, now you can remove this 2 ohm resistance. Okay, what is the potential at this junction is nothing but 5 volt, right? Okay, now this 5 volt is there. Okay, so can you tell me what will be the current here? So you know that 10 minus 5 by 2, which is nothing but 5 by 2, which is 2.5. Yeah, which is going to be 2.5. Okay, 2.5 will be the current flowing through this network. Okay, like, okay, and if this current is flowing here, so this current will flow there also, right? Now can you tell me what will be the current here? So it will be 2.5 only. So I'm just writing 2.5 ampere is equal to 5 minus 3 volt, 5 minus 3 volt upon the resistance is RL, right, which is unknown. So RL is going to be 2 by 2.5 ampere, which is nothing but, you can say that now you can prove it, right? So it is going to be 0.8 ohm. Okay, so this is the answer for this question. That is why C is going to be the right answer for this question. I think this is clear, right? So you have to imagine that the resistance, okay, across this load network is going to be same as the RL, sorry, same as the source resistance, or you can say RTH. ठीक है, तो ये क्वेश्चन बहुत इजी हो जाता है. तो आंसर विल बी 0.8. लेट मी गो टू नेक्स्ट क्वेश्चन. आई मीन द सेम क्वेश्चन विच वाज आस्क्ड इन 2012. And let me tell you guys, this year the topper marks was 67 out of 100. Okay, in EC paper the topper marks was 67 out of 100. So you can understand that the question paper was like considered to be difficult those days, but that was not difficult. But yeah, because it depends upon how you are going to like who is teaching you and what kind of content you are studying, right? That matters. Otherwise question was not difficult at all. Now you see this question got repeated, right? So let us solve this question as well. So this is a circuit A. Now they did not mention it is a source network. They said that the circuit A. See, if you follow Hayat and Kimberly Hayat and Kimberly book, right, for network theory, so you will find this kind of circuit, right? Okay, they have given this kind of same circuit you will find in Hayat and Kimberly book. That is why I suggest कि आपको जब टाइम मिले तो एटलीस्ट ट्राई टू वॉक थ्रू सम रेफरेंस बुक्स करस्पॉन्डिंग टू ईच सब्जेक्ट. तो एटलीस्ट यू विल बी हैविंग एन आइडिया कि अच्छा ये सर्किट तो आपने पहले देख रखा है. तो जब आपके गेट में क्वेश्चन आएगा तो आपको ऐसा नहीं लगेगा कि ओ दिस इज अ न्यू क्वेश्चन और काइंड ऑफ थिंग. नाउ लेट्स सी दिस गाय. So there is a capacitance. See, this is a AC minus J1. Okay, so this is a capacitive reactance is also given, and okay, this is kind of you can say kind of impedance is given here. Okay, and all guys are DC only. So you can imagine this is nothing but an open circuit only. So it does not make any change in your circuit. ठीक है. So इसको आप क्या कर सकते हो, इसको इग्नोर कर सकते हो. ठीक है, यू कैन इग्नोर दिस गाय, यू कैन ट्रीट दिस गाय एज ओपन सर्किट. तो अब ये क्या हो जाएगा, देखो यहाँ पर मैं एक बार ड्रॉ कर देता हूँ. तो द क्वेश्चन इज, यू कैन इमेजिन, आप पहले ये सोचो ये क्या है. दिस इज 2 ohm, दिस इज 10 volt, राइट? So what will be the voltage across this? There will be a voltage, you can say 5 volt, because we are considering that the resistance appearing at this juncture is gonna be equal to this guy. Now you can connect back the load resistance also, I mean load network or circuit B network. Okay, so आप इसको connect कर सकते हैं. तो R and 3 will be there. This is R and this is gonna be 3. Okay, and it is a DC only. They have used this kind of symbol, but don't get confused, right? It is a constant bolt only. Now, I think anybody can solve this question, right? So now what you have to do, you have to find the current, which is this current is going to be 10 minus 5 by 2, okay, which is 5 by 2, which is 2.5 ampere. Same current is flowing 2.5 ampere, and this current will flow here also. Okay, ऐसे जाएगा. Okay. Now imagine there is a current 2.5. So what will be the so 5 minus 3 by R, which is equal to 2.5. So आपको R निकालना था, तो 2 by 2.5, which is 0.8. Okay, so it's a very simple solution, right? मुझे ऐसा लगता है कि you guys may not be thinking like this. ठीक है, अब इसमें आपकी मिस्टेक नहीं है. सी suppose I am teaching you maximum power transfer theorem or Thevenin theorem. So I will tell you that these are the situations where you have to use. Okay, so whenever you are applying Thevenin theorem and all, so remember that it will be a black box and you have to always look back like this. Okay, आपको यहाँ से देखना है कि yes, and you have to treat entire black box as what? Entire black box as the single voltage source and along with the RTH. Okay. Now you must know that what will be the BTS and what is going to be the RTS, right? And one more thing is there. Suppose let's say this is a black box, right? And there is only, you can say, dependent sources are present, right? You can say some dependent sources. Okay, a dependent source and only resistance and the dependent sources are present. Okay, only dependent source and resistance is present, right? Only. And मान लो यहाँ से आप देखते हो, so if someone is gonna ask you what is VTH and what is RTH, right? So VTH will always be 0, guys. Remember that. Okay, you can directly write the VTS is gonna be 0. So this entire black box will be the equivalent of this entire black box is gonna be RTH only, guys. Okay, only RTH. Okay, you cannot get a VTH. Okay, because there is no source voltage. Okay, there is no independent voltage sources. Okay, only dependent voltage source and the resistance is there. No sources are there who are going to energize your network, right? So your VTH will be directly 0. You don't have to waste your time. ठीक है, तो जब भी question आएगा and if you have to find VTH, and please make observation that in that network whether from where you are looking back, okay, into the network, आपको ये देखना है कि whether that circuit contain independent sources or not, right? ये चीज आपको कोई नहीं बताने वाला है, ये आपको खुद सोचना है, right? Okay, and remember that if there is a single source present in the circuit, मतलब single source अगर present है circuit में, so that will always deliver the power. Okay, that will always deliver the energy. It cannot absorb the energy or power. Remember, this is important point. Okay, it will always give back to the network only, right? That is why we apply some sort of source, okay, to excite the network. तो अगर सिंगल दिया है, मान लो मल्टीपल सोर्सेस हैं, so yeah, situation might happen that the voltage, I mean the power can get absorbed, delivered, so many things can happen. But if there is a single source, ये सारे पॉइंट्स आपको लिखना है, शॉर्ट नोट में लिखना है, क्योंकि जब मैं आपको नेटवर्क थ्योरी बताऊंगा इन डिटेल, राइट? ओके, अभी तो मैं आपका डाउट सॉल्व कर रहा हूँ जो भी है, तो यू विल मास्टर दीज टेक्निक्स. ठीक है, तो गेट एग्जाम में क्वेश्चन इतने सिंपल आते हैं, इतने सिंपल कि अब क्या बताएं, राइट? सो थैंक यू सो मच गाइज, आई होप आपको ये समझ में आ गया होगा. ठीक है, तो ऐसे क्वेश्चंस अगर आते हैं गेट में तो आप हैप्पली कर सकते हो, राइट? और एसी सर्किट में तो बहुत ही इंटरेस्टिंग कॉन्सेप्ट्स हैं, है ना, उनको भी हम बताएंगे. सो आपको जो भी डाउट आता है, आई एम ओपन टू सॉल्व योर डाउट ऑन लाइव सेशन. यू कैन शेयर योर डाउट.